All right, let's keep going with our exam review. This is the part 2 to that. I want to study problem number 208 from the exam review. Okay, then here it is. And what we want to do is find the value for k that makes the function be continuous. Super. Well, that means we need the limit from the right to equal the limit from the left. So we need the limit as x goes to 1 from the right of this function to equal the limit as x goes to 1 from the left of this function. But that's right where the domain is split up. So instead of me writing f of x, why don't I just put the pieces of this piecewise function right on in. Okay. So this is what we need, but wait a minute. This is a polynomial, and this is a polynomial. They're both linear functions. So you can evaluate their limits. This limit right here is what you get when you stick a 1 in. It's 5 plus 3. That's 8. This limit over here is what you get when you stick a 1 in. That's 2 plus k. Now you have an equation with one variable. Evidently, k is just the number 6. All right. How about some problems of properties of limits? Let's see. Well, I'm not seeing any that I like. I'll just have to make one up. That's no problem. So, these problems are really pretty easy. What happens is they say let the limit as x goes to 1 of f of x be some number, like maybe 2, and the limit as x goes to 1 of g of x is some number like, I don't know, minus 3, and then they want you to calculate the limit as x goes to 1 of 6 times f of x minus 1/2 g of x, something crazy like that. Or let's do 1/3 g of x. There we go. This big function. Well, that's easy, right? The official thinking is that the limit of the sum is the sum of the limits, and the constants can come out in front of the limits. So officially, you would rewrite this as 6 times the limit of x going to 1 of f of x minus 1/3 the limit as x goes to 1 of g of x. And each of these limits are numbers. They are the numbers 2 and minus 3. So you would end up with 6 times 2 minus 1/3 times minus 3. And you would get 12 plus 1. That's 13. All right. talk about average rate of change. Looking at my exam review here. Okay, question 109. Find the average rate of change between 2 and 5. Okay, so this is some parabola looking function, and I'm just making a sketch of it here. And it looks like when x is 2, that we are getting a y value of 7. And when x is 5, I want to say that it's 1. Let us say that it's 1. So then that means our parabola goes through the points 5, 1, and it goes through the point 2, 7. Then you need only find the slope of the line through those 2 points. The secant line. You want the slope of the secant line through those 2 points. And it goes down how many units? My drawing is way out of perspective here, but it started off with a y value of 7 and it wound up at a y value of 1, so that's a decrease of 6 units. So the rise is -6, and then it has to run from 2 to 5, so that's a run of 3 units. Then we would have a slope of -2. That is my average rate of change for that function. All right, and then let's look at 111 here. 111 is asking us to on this graph, which point will have its slope closest to 0? Well, that's got to be the point that's at the vertex of that parabola. Because just to the left of it, the tangent line had a positive slope, and just to the right of it, that tangent line had a negative slope, and right at the tippy top, the slope of that tangent line is 0. If I wanted you to tell me at which spot the slope of the tangent line was closest to 2, if I wanted to know the spot on that tangent line, if I wanted to know the spot on that parabola where the slope was closest to 2, then it would have to be something over here on this side, because all of the points over on the other side would have negative slopes for their tangent lines. Okay, so expect on the test to have 13 questions that are either multiple choice or whatever, multiple choice or like, you know, a choose all that apply type of thing. And then after that, there's 2 questions where you have to type out your answer. And I guess before we do the ones where you would have to type out an answer, you know, you're going to want to know what the definition of continuity is. and you're going to want to know the definition of the derivative let me see. Yeah, the definition of the derivative is the very last section that you study before this exam. It's 1.6. The definition of continuity, that was where your limit towards a point on your function was just equal to what you got when you evaluated that function at the given point. If this is satisfied, then continuous. So if this, then continuous. To say it in reverse, then if continuous, then you know that you have this limit. Okay? And the definition of the derivative, that's, you know, the limit as z goes to w of f of w minus f of z over w minus z. Quite often that is stated, so to me, in my world, this is the definition of the derivative, but the majority of people like to make it harder, and they instead want to study the limit as h goes to 0 of f of x plus h minus f of x all over h. And I assert that they are identical. And for you to see that, then all we need to do is say let w equal x plus h, and let z equal x. Because if I did such a thing, then this limit, instead of z going to w, it would be x going towards x plus h. Well, if x is approaching x plus h, then you're just letting h shrink down to 0. And the f of w would be f of x plus h minus f of z. Well, that would be minus f of x, and it would be over w minus z. Well, w is x plus h, and then minus z, that'd be minus x. Now the x's in the denominator cancel out because they add up to 0, and now you have the very same thing that we had over here. And your interpretation of the definition of the derivative is that it is an instantaneous rate of change. It is the instantaneous rate of change. Because if I get rid of these limits, then what you have is the average rate of change. So for the secant line, it's the average rate of change. For the derivative, it's the instantaneous rate of change, and this instantaneous rate of change is exactly the slope of the tangent line. The average rate of change was the slope of the secant line. The average rate of change was the slope of the secant line. All right, let's get a understanding of what the difficulty level of our fill in the blank questions might be. So you might be asked to state the definition of the derivative. I mean, if I was asked to state the definition of the derivative, I would put down one of these limits. If I was asked to state the definition of continuity, I would at least be writing down this. But if you want to be absolutely correct, you would have to say that the limit exists and f of a exists. They both need to exist. And then finally, if they both exist, they must also equal to each other. And then you would probably have a problem to work out, such as a problem where you have to use the definition of derivative. You would use the definition of derivative to find the derivative of some function. While you probably end up doing this in 1.6, you were doing it before 1.6 as well. Because if I gave you a function like f of x equals, let's say, how about x squared minus 6x plus 5. There's my function. And what I would like from you is the limit. What I would like to know from you is to find the derivative at x equals to minus, no, yeah, let me think, at minus 1? No. Well, it doesn't matter. Let's do it at 10. Okay. But this is to find that derivative is the exact same problem as to find the slope of the secant line on the interval 10 to h. Because you would have to find f of h minus f of 10 over h minus 10. And f of h would just be h squared minus 6h plus 5. And then minus the f of 10. F of 10 is going to be 100 minus 60 plus 5. And down here you have h minus 10. So this quotient would be h squared minus 6h, and this stuff in parentheses here is just 45. So it's a 5 minus 45. So that would be minus 40. Okay, I would use, you can either factor or you can use your synthetic division. I love synthetic division, so I will do that. I put my root of the denominator, which is 10, and I put my coefficients of the numerator. The 1 comes down. 1 times 10 is 10. I add the minus 6 and the 10, and I get 4. And then repeat. 4 times 10 is 40. You add those together, and you get 0. So then these are the coefficients of performing that division. And here you would get h plus 4. So I would know that the slope of the secant line on the interval from 10 to h is given by the expression h plus 4. And if I were to just stick a 10 in there, I would get 14. And you will now see that 14 is the slope of the tangent line, because we'd be looking at the interval from 10 to 10. It's right at that point. Okay, so to see that this is really just all the same thing, I'll use the difference quotient, the traditional difference quotient definition of derivative here, and you will see. You do not even have to use the traditional difference quotient of the derivative. You do have to use the definition of the derivative. So you either need to take the limit you either need to finish erasing. You would need to study the limit as h goes to 0 of f of x plus h minus f of x all over h, or you would need to use the limit as z goes to w of f of w minus f of z over w minus z. They are the same thing. You must use one of those. I will use this one here, the difference quotient one. And okay, great. So this would be the limit as h goes to 0 of an x plus h squared minus a 6 times x plus h, and then plus 5, and then minus f of x. There's my x squared minus 6x plus 5. And it is all over h. Okay. So I'd be looking at the limit as h goes to 0 of x squared plus 2xh plus h squared a minus 6x minus 6h plus 5, and then I'll distribute by negative, minus x squared plus 6x minus 5. And we get some nifty cancellation. We are going to get cancellation on the 6x's and on the 5's and on the x squareds. In fact, all of these terms must cancel or you have made a mistake. Then now each remaining term has an h. I factor the h out and cancel it. So I'd have the limit as h goes to 0 of 2x plus h minus 6. I'm sorry, I meant to say 2x, not 2h. Because I'm canceling an h there, an h there, and an h there, and an h there. So I'm left with 2x plus h minus 6. And now you can do the limit. You don't have an indeterminate form anymore, so this would be 2x minus 6. And what happens if I stick that 10 in for x right there? It says 20 minus 6. That's 14. That's the same number we got just a moment ago. Now, if you don't like this, if this method confuses you, that's okay. That happens because of the x plus h business. You can definitely do it the other way with the f of w minus f of z over w minus z. Let's do it like that, and you will see that we still get 2x minus 6. So I'd want to take a limit as z goes to w of f of w minus f of z over w minus z. Okay, so I'd have the limit as z goes to w of w squared minus 6w plus 5 minus z squared minus 6z plus 5 over w minus z. Distribute the negative here, here, and here. And we would be looking at w squared minus 6w plus 5 minus z squared minus plus 6z minus 5 over w minus c. These 5's cancel, and it would sure be nice if we could get a cancellation on a w minus z. And you can. Do a little bit of rearrangement here. And it would say w squared minus z squared, and then minus 6w plus 6z over w minus z. You have a difference of 2 squares sitting right there, and from these other two terms they both have a 6 in common. So I'm going to be able to pull out that w minus z. We'll have the limit as z goes to w, And I'll factor that difference of two squares, so it's w plus z and w minus z. And then I'll factor out a minus 6 and be left with w minus z. And then down here in the bottom, I have a w minus z. So you factor out the w minus z everywhere and cancel it on top and bottom. And then you'd be looking at the limit as z goes to w of w plus z minus 6. You can now evaluate that limit. It says w plus w minus 6. That's just 2w minus 6. Same thing. All right, that should be the whole test. That's the end of our review session. Study up and good luck. Let me know if you have questions.